Okay guys, in this video we're going to review a little bit our law sines, law cosines. So something we've been looking a lot at, but specifically on 32A here, what I want to look at is a situation where we're using the law of sines in order to solve a side-side angle case. And so how do I know, first of all, that this is side-side angle, especially when I've got things set up down here this way? Well, first things first, we should probably reset this up. And so I guess what I would tell you is, as we've been writing it, we've just been saying lowercase ABC and uppercase ABC. So I would encourage you to actually, even though this is written here like this, rewrite it. And let's fill in what we know. We know that this is 40 degrees here. We know that A is 21, and we know that B is 28. But instantly this hits me right in the face that, hey, first of all, I can use the law of sines. I have a side angle pair. But furthermore, I have two sides and an angle. So this must be the side-side angle case, or you could look at it as this case right here. I hate to put that on my video here, but hey, you know, that's the big red flag for it. You have to be careful here. It's law of sines where you have two sides and an angle. So when you look at it this way, the very first thing we have to go solve for is B. We don't have a whole lot of choice. So keep in mind that our law of sines says the sine of A over A is the sine of B over B is the sine of C over C. We're going to go ahead and set up a proportion here with our side angle pair we have at A. So we say the sine of 40 degrees over 21 would have to be the same thing as the sine of B over lowercase b. Now, one thing to keep in mind here that's pretty important is we're going to go ahead and solve this like we typically would with a law of sines problem we do in cross products. We get 28 sine 40 degrees. But the thing to keep in mind is that we're solving for b, which means I really need to get this trig function by itself first and then use an inverse sine. So we're going to go ahead and divide both sides then by 21. What this means though is that the sine of b is actually equal to 28 sine of 40 degrees all over 21. So now, solving for b, we kind of have to undo the sine, which means we have to do a sine inverse of both sides. And finally we arrive at this conclusion then, well, the angle B must be the sine inverse of 28 sine of 40 degrees all over 21. So I'm going to put a box around this. We're going to go ahead and get our calculators out here, and I'm going to go ahead and evaluate for this. So a little bit in pieces for me here. I'm going to go ahead and do 28 sine of 40 degrees first, and then I'm just going to take that answer divided by 21. And so what I end up with is this number here. What I want to do is take the sine inverse of it though. So sine inverse of my answer gives me this, that it's about a 59-degree angle here. And so this says round angles to the nearest degree. I'm going to say B is about 59 degrees. Now here's the rules. If it is angle side-side, if it is this case here, once you find angle B, we're going to go set up a second triangle, as if maybe there's a second triangle that could work, because there's possibly a second triangle that could work, except for on all of these we're going to write primes. And what I mean is, these aren't A, B, and C, capital A, capital B, capital C. These are A, B, and C, capital A, capital B, capital C in the second possible triangle. So how does this work? What do I put in here? Well, first things first, let's go ahead and put in the things that were given to us in the first place. In the second possible triangle, we still have the same three initial values that we were given. It's just that for this angle B here, what we have to do is this. Take 180 minus the angle that I just found over here. So it's like the first thing I race and go do. Like, oh, hey, I have B. Let's go see if another triangle works. And see, here's the thing. With this triangle here, if I take 180 minus 59, what that would mean is that the second possible triangle has a 121-degree angle for its angle B. So what I want to argue is this. Is it possible for a second triangle to have two angles, one of them be 40 and the other one 121? And all you really need to ask yourself is, I don't know, did they already add up to be more than 180? Because if they don't, then what we could say is, well, hey, you know, 40 plus 121, that's 161. If I take that away from 180, then what I get is 19 degrees. It means that in this triangle, angle C prime has to be 19 degrees. However, over here on the left, when we found 40 and 59, this was our first possible triangle. Well, I know that 40 plus 59 is 99, and we could take that away from 180. It would mean that in the first possible triangle, angle C must be 81 degrees, 81. And so what would I go and do from here? Well, I suppose that the only thing we have really left to do is find the side length C, but we would have to find it in the first triangle separately from the second triangle. So in this particular case, let's go ahead and pick on how would I solve for lowercase c here. So, you know, I'm not going to do this one here. I just need some room to write. So let me get that out of the way. But I'm going to say c over the sine of 81 degrees in our first triangle would be equal to our side angle pair, 21, over the sine of 40, which was the angle opposite here. And so we're going to go ahead and work backwards here. We would say c times the sine of 40 degrees would be equal to 21 times the sine of 81 degrees. And so c would be equal to 21 sine of 81 degrees over sine of 40. So let's go ahead and get a value for this here. We need, get my calculator back out here, 21 times the sine of 40 degrees, taking that, let me put 40 first, divided by the sine of, 21 sine 81. I take that back. 21 sine 81. That was close. Divided by the sine of 40 degrees. This should give us the length of C in our first triangle. So in the first triangle, we get about a 32 point, and this is to the 10th, 32.3. So I'm going to write 32.3 here units long. Now when we go over to the second triangle, you'll notice that some things stay the same, some things change. This time though, we're going to say, excuse me, let me switch back to my pen tool here. We're going to say C prime over the sine of C prime, which in this case is 19 degrees, is equal to 21 over the sine of 40 degrees, which was our side angle pair we were given. So this time, excuse me, solving for this, we get C prime times the sine of 40 degrees equals 21 times the sine of 19 degrees. But solving for C prime this time, we would get 21 sine of 19 degrees, this time over the sine of 40 degrees. And so in our second possible triangle here, we'll go ahead and evaluate for this here. We have 21 sine of 19 this time, and dividing that by the sine of 40 degrees. What we get instead is about a 10.6 unit length, side length here. So you have to solve for both of your triangles here. Now, what is it that I'm going to write up here? Well, in terms of what you found, I would say that we found that this was 59 degrees, capital C was 81 degrees, and then lowercase c is 32.3 units long. But in our second possible triangle, we found out that capital B prime was 121 degrees, capital C prime as a result was 19 degrees, and then little c prime, which we just solved for using law of sines, is 10.6. So just be mindful that if it's the side-side angle case, or if you can use the law of sines and you have two sides in an angle, the moment you find this first angle, go set up a second triangle and take that angle away from 180, because you're going to ask yourself, could I make these two angles? Could I add these two angles together and still be under 180? Because if you can, then it guarantees an angle here. Just to throw something out there. If in this video we had found that angle B here was, say, 40 degrees, 42 degrees, then I would have had 180 minus 42, which would have left 180 minus 42. It would have meant that this angle here would have been 138. So I suppose that still works there. I'm trying to throw it off here. Hypothetically, let's say that this angle over here was like 160 degrees. Well, 160 and 40 add up to 200. If that were to happen, you would just say, doesn't work. But because it does, we had to pursue the answers there. Cheers.